So, okay. So now, next step, that is step number 6. So for in the step number 6, we have to provide the anchor bolts and we have to decide the size of cleat angle. So in step number 6, we will write provide provide four number of provide four number of anchor bolts, four number of anchor bolts to connect base plate and connect base plate and, or we can say to connect base plate with concrete pedestal, base plate with concrete pedestal. So concrete pedestal of 20 diameter. So because anchor bolts having some diameter, so we have to write specific which diameter you are using. So four number of anchor bolts with 20 diameter. Full stop. Also provide two number of cleat angle, two number of cleat angle. So generally greater size cleat angle we have to provide here. Two number of cleat angles 150 by 115 by 10 we will provide. So you can provide 150 by 125 by 10. Okay. So here we are providing two cleat angles of 150 by 115 by 10. So as per your wish, you can provide. You can provide 150 by 125, or you can provide 125 by 110. As greater size of angle we can here provide with thickness of 10 or 12 So this is the step number 6. Now step 7. Calculate the size of concrete pedestal. Concrete. Calculate the size of concrete pedestal. So for that we have to calculate first area of foundation or area of concrete pedestal, that is AF is equal to, the formula is P into gamma m naught divided by SBC. So whether SBC value is given in the problem statement. I think SBC value is not given, so we have to assume SBC. So here we will assume so generally for hard murum or hard strata, SBC value will be greater than 200 kilonewton per meter square. So here we will assume 220 kilonewton per meter square. SBC value. So we have to assume generally if you have to assume, so assume greater than 150, 150, 160 up to 250. So this is the value for hard strata. So now calculate this area of foundation. So P 1000 into 10 raised to 3 into gamma m naught is 1.1 divided by SBC is 220. This is kilonewton per meter square. So we have to convert into Newton per mm square. It means we have to multiply by here 10 raised to, so kilonewton, this will be the 10 raised to 9. So this value will be, I think, 10 raised to 3 or 10 raised to 6. 10 raised to 6. Kilonewton, the conversion of kilonewton to Newton 10 raised to 3. So divided by, so meter square to mm square. It means 10 raised to 2 into 3. So it will be a, so that we have to multiply by 10 raised to 2 into 3. So this value will be 10 raised to 9. Is this correct? So how much is this calculation is correct? 10 raised to 9 or 10 raised to 6? So how much this value? Is this correct? Or do the calculation? I think something went wrong. So kilonewton into Newton divided by this 10 raised to 2 into 10 raised to 3. So this will be 10 raised to 6. So this will get cancelled. I think this will be the 10 raised to 3. Please, anyone can tell me the answer. एवढं माझ्या एवढं तुमचं मॅथमॅटिक्स तर कच्चं नाहीये. Do the calculations. This is the value in kilonewton per meter square. So we have to convert into Newton per mm square. And we have to do the calculations. I think माझ्यापेक्षा कोणच हुशार नाही तुमच्यात. This will be 10 raised to 3 divided by 10 raised to 3. So this 10 raised to 10 raised to 3 get cancelled. So here, now 1000 divided by 220, how much? So you have proved that no one is clever than me. मी तुम्हाला किती उशीर झालं म्हणतोय कॅल्क्युलेशन सांगा. कसं होतं, हे किलोमीटरचं 10⁻³ डिवायडेड बाय mm² आहे. तर सॉरी मीटर स्क्वेअर. सो मीटर स्क्वेअरचं mm² करायचं आहे. सो त्याचं सेंटीमीटरमध्ये कन्वर्जन केलं 10⁻². हे कन्वर्जन सेंटीमीटरमध्ये. सेंटीमीटरचं परत मध्ये कन्वर्ट इंटू 10⁻². इट मीन्स पॉवर ऑफ 3. सो दिस व्हॅल्यू विल बी 10⁻6. सो दिस 10⁻6 कुठं जाईल, या वरच्या बाजूला आलं. दिस 10⁻6. दिस 10⁻³ and 10⁻³ get cancel. So 1000 into 1.1 divided by 220 is 5 into 10⁻6. Okay, so this is the area of foundation. Now we have to calculate length of foundation. So length of foundation is equal to LF is equal to, use this formula, LP minus BP divided by 2 plus under root of LP minus BP by 2 square plus AF. So now LP is 400 minus BP is 280 divided by 2 plus under root of again 400 minus 280 divided by 2 square plus this 5 into 10⁻⁶. So tell me now length of foundation. Do the calculations. What is the value? How much length of foundation? 2311.13. 2311.30 mm. So we will increase this. We will provide 2500 mm. 2.5 meter. It means we will provide 2.5 meter. So again, but area of foundation is equal to length of foundation into width of foundation. So now length of foundation and area of foundation is known. So calculate. So here area of foundation is 5 into 10⁻⁶. Length of foundation is 2500 into width of foundation. So width of foundation, so here so width of foundation, this PF is equal to, so tell me the answer, 5 into 10⁻⁶ divided by 2500. 2000 exact. Okay. Okay, so you can increase or you can keep as it is, no problem. So you can increase by 100 mm, no problem. Okay, so this is the your width of foundation. Now calculate depth. So now depth of foundation is equal to how much? How to calculate? Length of foundation minus length of plate divided by 2. So length of foundation is 2500 minus width of plate is 400 divided by 2. So depth of foundation df is equal to how much? So how much depth of foundation? 1050 mm. So provide size of concrete pedestal is 2500 mm by 2100 mm by 1050 mm. So this is the size of concrete pedestal. And now last step, that is step number 8, is step number 8, design of welded joint. Design of welded joint for column and base plate. So in that we have to calculate first total available length for welding. Total available length for welding. So we have, so this is the L available. So as we have given the formula 2 into PF plus BF minus TF plus D minus TF. So 2 into width of flange we have written 250 plus 250 minus TW how much? Please go to steel table. I think 8.3 is there, plus depth of section is 350 minus thickness of flange is 11.6. Is this correct? So tell me how much available length is there? Sixteen 60 by 2, 1660.2. So this is the available length for welding. It means if we this is the your, so this is the your ELP, this is the your width of plate, this is the depth, this is the width of flange, this is the TW, this is the TF, and we have to weld in this area. So this is the available method that we have to calculate. So now number 2, we have to calculate strength of weld. So strength of weld is equal to your FUW divided by under root of 3 gamma EMW into T into LE. So effective length we have to calculate for that. So in step 3, sorry, here we have to take first calculate size of weld. We have to assume size of weld. So size of weld is equal to, so how to calculate size of weld? As I told you, it is depends upon the thickness of plate. So our thickness of plate is 12 mm. So thickness of plate is 12 mm. So for that you have to go page number, which I think 48. On the page number 48 they have given. So size of weld for 12 mm plate is a 5 mm. Please go to page number 48 or 30. I think 48. IS 800 2007 for 12 mm. It means size of plate uh, less than 10 mm thick, I think 3 mm, then 10 to 20, I think 5 mm, then 20 to 32 to 6 mm, and greater than 32 to 50, I think 8, and greater than 50, maybe 10 or 12. Like this, the table is given on the page number. So size of weld we have to select from the thickness of plate. So thickness of plate we have to assume or calculated is 12 mm. So for this 12 mm, 12 it means 10 to 20. So 5 mm we have to select. Are you getting? Okay. So now, so throat thickness. Throat thickness we have to calculate. Throat thickness T is equal to 0.7 into S. So 0.7 into 5. So 0.7 into S. So 0.7 into 5 is equal to how much this throat thickness? 3.5 mm. Okay. So we will put this value in the effective length formula. Then number 3 we have to calculate effective length for the weld. Effective length for the weld. How to calculate effective length for the weld? By equating factored load and factored load and okay, by equating factored load and strength of weld. So factored load P is equal to strength of weld FUW divided by under root of 3 gamma MW into T into LW. So we have to calculate this effective length. So here factored load is 1000 into 10 raised to 3 is equal to FUW. FUW is the how much ultimate strength. So ultimate strength is 410 divided by under root of 3 into gamma MW is the 1.25 into this T 3.5 into LW. So calculate LE. So calculate LE effective length. So this calculation we have did earlier in chapter number 2, chapter 3, 4, welded connection. When design of welded connection was there, at that time we have did these calculations. Factored load and strength of weld we have equated. So the strength of weld formula also many times asked for the MCQ also. Strength of weld FUW divided by under root of 3 gamma MW into T into LW or LE. So how much the effective length? 1508.75. 1508.75. This is the effective length. And now we have to calculate the available effective length. So how to calculate available effective length? Number 4, we have to calculate available effective length. So available effective length for weld. So is equal to what is formula? Total length, total available length, total available length, total available length for welding minus 2 into size of weld. So now total available length is what? 1660.2 minus 2 into size of weld. So size of weld is 5. So how much this? It should be greater than your effective length. How much this? 1650.2. And our effective length is how much? So effective length is 1508.75. So hence provided size of weld is adequate for weld. Are you getting? In this way you can. So available. So now you can weld for this 1650 or 1505. 1508 ला वेल्डिंग केलं तरी चालेल. दिस इज दी युअर वेल्डिंग लेंथ. या लेंथ इफेक्टिव्ह वेल्ड. इट मीन्स यू हॅव टू वेल्ड ॲटलिस्ट दिस लेंथ 1508.75 1508.75 लेंथ. या लेंथला तुम्ही वेल्डिंग केलं तरी चालेल बिकॉज अवेलेबल is greater than this. So this is the your critical length to weld. So 1508 एवढ्या लेंथला वेल्ड केले तरी चालेल. ओके. So in this way you can solve the or design the slab base. So so the second type of column base is remaining to design, that is the design of gusseted base, that we will cover in the next lecture. So wait, I will take attendance first now, then, because our time is about to close. So here first type of column base we have designed, that is slab base, and second is remaining, that is design of gusseted base. So after the design of gusseted, our syllabus will be end. So next 2 hours to required to complete the gusseted base. Okay. So I have taken attendance, please you can left.